Hello, in this video you will see the coolest problem ever. Let's start. Derivation of a formula, problem number 5, and here is its formulation. Derive the following formula for n, which is a natural positive number, so any number n, the formula which looks like this. And now, in the course Mathematics Proofs by Induction, I proved this formula by induction. So this is how it looked. And again, in order to prove some formula by induction, you necessarily need to have the final result. So you must know the answer, because otherwise it will not work. But in the method I will present now, you really don't need to know this answer, because I will derive this formula in a way that it will simply become very clear what this number is. Okay, so now I look at these terms and I notice that the difference between the factors in each denominator is equal to 1. You see 2 minus 1 is 1, 3 minus 2 is 1, 4 minus 3 is 1, n plus 1 minus n is also 1. So in order to gain something, I will replace 1 in each numerator by the difference of the factors in the denominator. So it's actually nothing special, because 1 is equal to 2 minus 1, 1 is equal to 3 minus 2, and so on and so on. But it will help me a huge deal. So you will see that this idea is actually very strong, even if it seems like silly. So let's start. Now I replace 1 in the first numerator by 2 minus 1. So maybe I will write down all the terms here, 2 times 3. And then I will go with a red pen and replace all the ones in the numerators by the differences of the factors in the denominators. So here is 3 times 4, and so on and so on. So the last but one is this one, and then at the end we have n plus 1, right? And now here in the second numerator I put 3 minus 2, here 4 minus 3, n minus 1. Here you see it's important with parentheses, because without this parenthesis it would be just wrong. And the last one, n plus 1 minus n. So in all the fractions, the number in the numerator is just 1, but it's kind of written in a smart way. So why is this way so smart? Because now I can split each fraction in 2 fractions. I will first do it, and then I will explain why it is a valid operation. Well, of course, if I now denote this by Sn, it is still Sn, right? Because even after this rewriting, I have still the same value, because I didn't change anything. I just replaced once by the differences of 2 consecutive natural numbers. So it's nothing happened here. And now I will split each fraction into 2 fractions. So the first one is 2 divided by 1 times 2 minus 1 divided by 1 times 2. And I claim that this one is equal to this one. Why is it so? Well, it is easier to think about it from the row below to the row up. Why? Because you see here, in this place, I just have a difference of two fractions with the same denominator. And you know that if I already have the same denominator, I can subtract fractions by subtracting the numerators. And this is exactly what I get here. So you see it is exactly the same fraction, but written as a difference of two fractions. So I can continue in the same way with the second one. So here it will be 3 divided by 2 times 3 minus 2 divided by 2 times 3. Exactly the same reasoning, but to a different fraction. And I will write the next one. It is again 4 divided by 3 times 4 minus 3 divided by 3 times 4. Some color here, maybe this one. And now I just write 3 dots. And then I take the last but one. So here I will get first n divided by n minus 1 times n minus, here I don't really need parentheses because it's just standing here, n minus 1 divided by n minus 1 times n. So this one here corresponds to this one. So I have still one more to go, the last one, and here I will get n plus 1 divided by n times n plus 1 minus n divided by n times n plus 1. Okay, do I have some nice colors here? Maybe blue. Blue is nice. And now you will see the coolest thing ever. Now I take the red pen and I will perform plenty of cancellations. Because you see, the very first fraction you see here can be simplified by dividing both numerator and denominator by 2. So these two 2's will just disappear. Of course, then you will get 1 in the numerator, right? Here, in this fraction here, I can simplify it by 3. So this will disappear. The next one can be simplified by 2. The next one by 4, by 3, and so on and so on. You see what is happening, right? Here, n plus 1, n plus 1, and an n. And now, to be very clear, I will rewrite them properly, so that you don't believe that those numbers which I cancelled in numerators just disappear. No, they turn into 1 after division, right? So here, the first number here, this number is simply 1 divided by 1. So this is 1. Then here is simply 1/2, right? So I'm done with this first parenthesis, which was light green. Then I move to the orange one, and in the orange one I get 1/2 minus 1/3, right? So here is this orange part. Then I move to the gray part. The first fraction is 1/3, the second one is 1/4. And then it continues. Here I take the gray, and the next one will be this green. And here the first fraction will be 1 divided by n minus 1, minus 1 divided by n. And the last one is the blue one. And the blue one will be 1 divided by n minus 1 divided by n plus 1. You see what's happening now, right? You see that I have minus 1/2 and plus 1/2, minus 1/3 and plus 1/3, minus 1/4, and you know that in next parentheses I have plus 1/4 minus 1/5. So this will cancel out with the plus 1/4 from the next parenthesis. And then this 1 divided by n minus 1 will cancel out with minus 1 divided by n minus 1 from previous parentheses. Minus 1/n cancels out with plus 1/n. And the only thing which is left here, it is the very first one from the first green, not this green, this one, green parentheses, and negative 1 divided by n plus 1 from the last one in blue. That's all. All the rest cancelled out. Isn't it beautiful? So now I can put these two together by rewriting 1 as n plus 1 divided by n plus 1, because now I have the common denominator, right, for both fractions. And now, because I already do have a common denominator, I can put these fractions together. N plus 1 minus 1, it is n. And you see, this is exactly what I was expected to get. And you see that the way I derived this formula didn't really require that I knew the result in advance. Not at all. I didn't know, but I knew, but I didn't have to know this result in advance in order to perform this computation. And I hope that you liked it, and if you did, you can go and check this out on Wikipedia. This kind of sums are called telescoping series, or are kind of connected to the topic of telescoping series. So you can read about it if you liked this method. Thank you for watching. Bye bye.